Hey, good morning, everyone. Thank you for having me here. Thank you for joining. So, just quick introduction about myself and the topic. I'm Dinesh Pillai. I work for Meyer, local to Grand Rapids. Uh, I am a solution architect by profession, and I mostly work on helping companies to deliver their enterprise architecture strategy and roadmaps, things like that. And this is specifically about DevOps. So I think the topic is clear, DevOps, and it's an old topic, but we are kind of looking into more from a theory and strategy standpoint. Then see how those can be implemented through an Azure service called Vsds. So, yep. We can get started real quick. So, I think this question is actually very stupid. I would say most of you would know what DevOps is these days. Just out of curiosity, anyone doesn't know what DevOps is? Okay. This is what exactly I was expecting. But when you talk about DevOps, everyone has their own view of DevOps. When I talk to some QA folks, they have their own notion of DevOps. Same thing with an operations guy, or my executive, my boss or my VP has a different view of what DevOps is. So this session is kind of looking DevOps from all angles, and just to make sure that your organization also covers all of those areas rather than silos. So by definition, I don't want to go through that, but just for the sake of it, DevOps is the union of people, process, and products to enable continuous delivery of value to end users. So that value is the word we need to really look through here. So how you can deliver value efficiently, that's all about DevOps. So I just wanted to quickly go through some more basics before get to the VSTS part of the session. Every system you look at, if it's cloud ready, if it's DevOps ready, or does it support your cloud readiness, you need to look something called 12-factor app. Again, very popular in the industry. So I'll just quickly brush through that. I assume most of you are aware of this, so I don't want to spend too much time on these slide decks. So number one, code base. It says you should have a simple code base. Dependencies, all the dependencies should be managed through some kind of explicit dependency management system, like Mavenizing or NuGets, config. This says your application should manage all the configs externally. Factor number 4, backing service. It's all about, let's say you have a DB service or a file share or any kind of external stuff. Let's say your application is talking to S3. Any of that should be managed as URL rather than direct hard coding. So build, run, release. That's the factor number 5. It's about you should have some kind of build and release and run happening, but it's all should be separate. Stateless processes, that's the factor number 6. So all your applications should run stateless, and it should be mutable. Port binding, all those stateless services or any kind of service should have some kind of port binding. So if you are familiar with things like Docker, things like that, implement that from a implementation standpoint. Concurrency, like this is all about how many services you can host and can you horizontally scalable on the fly. Disposability. So can you take an application or service down in real time and still service your customer the same way your earlier number of services used to service? Availability could be an issue, but you should never have a outage, or the customer should not be feeling like that the service is not available to him or her. Factor number 10, dev prod priority. So your dev environment or non-prod environment should be as similar, as close to your production. That's about factor number 10. 11, centralized logging. So you must be having a lot of logging mechanism, a lot of diagnostic mechanism. Use some kind of centralized logging to suffice that. Like I know people from AppD is here, and we can probably use something like that, or Splunk, or there are multiple solutions out there. You have open source like Elk. So all of whatever I am talking about, there are multiple ways to implement. This is just theory behind it. Finally, admin processes like monitoring or any other, any managed service. You should have some kind of centralized mechanism to self-service your development community, rather than placing a request and waiting for someone to suffice that. So modern public clouds like Azure, AWS, or GCP, or even you can implement your own OpenStack stuff. So all these things kind of implement that kind of self-service ability. Now let's go through real quick the building blocks of DevOps. So first thing, these things sometimes are kind of overlooked. First thing I would say in my mind, rather than technology, you should have some kind of lean, agile implementation in your company to kind of leverage your DevOps the maximum. So first go some kind of agile. In my company, we use something called scaled agile. So some version of agile. Development. Is your application development really geared towards cloud readiness? Is it really geared towards really getting the maximum benefit out of your DevOps strategy? You better take a look at your development platforms. What kind of platform you use. Are you kind of using things like domain-driven design or microservices-based architecture? So those are the kind of things which we talk at this stage. The third one is CI/CD, continuous integration, continuous deployment. I mean, most of the time when people talk about DevOps, they talk about that piece and that piece only. And this is all about build and release. I think most of you are aware of this aspect, so I will just skip that. Testing. Yeah, automation of testing. Again, in this section, I would focus more on the emphasis on unit testing versus integration testing and exploratory testing, because in the olden days you used to do a lot of UI-based testing or getting automated. Things have been changing. You need to get your feedback as soon as possible once something is out. So I would say more unit test case, little bit of API-based integration testing, and very, very less your UI-based test cases. Infrastructure, the other piece of DevOps. Again, we are talking about infrastructure as code, so how you can automate that. Are you kind of leveraging, or you can do multiple stuff here, like Chef, Puppet kind of total infrastructure automation, or you can actually get into more platform as a service, things like Cloud Foundry, Kubernetes, Azure Service Fabric. So that's all about that part, and then use containers within any of those stuff, so that you don't have to really manage your infrastructure. You don't have to worry about your underlying platform. The last one is probably a little bit difficult, culture, mindset, and I would also add organization structure in that. So many of the time, the DevOps mindset, the MVP mindset, minimum viable product mindset, is kind of missing. In terms of product management, in terms of developing or delivering a feature, or the last thing is, is your DevOps team within your company self-sufficient? Do they need to dependent? Are they dependent anything other than funding, anything other than money to an external team? Then I would say you have scope to improve there. So we have a lot to talk, but I would like to focus more on these 5 areas. Obviously, we will focus a little bit more from a VSDS standpoint on CI/CD. I probably, one thing tools cannot solve is culture mindset, so I cannot talk on that when I discuss tool. Before we even get there, DevOps has been around probably over a decade, and in the last 5 years, many companies have actually adopted DevOps. So I strongly recommend these 3 books in the same order. Just Humble and David Farley are like two like veterans in this area. So yeah, I mean the Phoenix Project, I'm sure many of you might have read. It's an awesome book. It's not even, you don't even feel like it's a textbook. So yeah, I would say go in that same order. So few quotes I wanted to just to run through from Just Humble. If it hurts, do it more frequently and bring the pain forward. That's one theme these guys have been talking about DevOps and in these books. So like when you try to culture that mindset in your company, the DevOps culture, you probably need to look into things like wherever you make mistakes, do it more rather than hiding from it. And the other thing is the earlier you catch defects, the cheaper they are to fix. That is from David. And again, it's all about, it's not just about testing or anything, it kind of tells a lot about, what you need to, what are the checks and balances you need to do when you design your DevOps pipeline, when you do your DevOps strategy. Try to figure out your mistakes as soon as possible. The later you find them, the difficult for you to fix them. Again, some of the another best practices I wanted to run by, incremental low risk releases. It's all about, how you minimize your production deployments. You can do multiple things like URIs, versioning, expand contract, blue-green deployments. It's all kind of, I don't want to go through in detail because we are running short of time, but these are pretty critical in terms of reducing your production deployment risk. So for example, expand contract, for example, says you deploy one version and the new version, and when you test your new version without exposing that to your customer, you switch that. And blue-green is very similar concept. The second thing is decoupled deployment and releases. So here we are talking about dark launches, feature toggles. I think it was Facebook who came up with this concept of dark launches where you release to only like 1% of your users, then kind of get a feedback and slowly increase to the rest of the 100% of the users rather than bombarding the new feature to your entire user community. Feature toggles kind of gives your business user an ability to turn off and on a feature. So essentially that kind of gives you some kind of way to decouple your deployment and release. Olden days we used to release and deployment happens almost together. These days, you can actually deploy your code, everything to production, but turn it off. And when your business is ready, they, in your portal, turn that feature on. And it is available to your customer, and if your customer doesn't like it, business has the ability to turn it off. That's essentially the rollback. And that doesn't have any IT involvement at all. So that's feature toggle for you. Then reducing the batch size. Again, it's all about once you have a piece of code, deploy it. So companies like Etsy, Amazon, they all deploy like 20,000 times a day to production. And that's all about one line of code goes through certain checks and balances and hits its production immediately. And the last and final best practice I want to talk about is optimize for resilience. Again, all these things came from Just Humble's book, so it is nothing I innovated or I improved. It's all straight from the book. So optimize for resilience. So it's all about the analogy between BMW and Jeep. So you have a BMW where it's designed for maximum performance, maximum reliability, but when it is down, it takes a lot of time and money to bring it back up. Whereas for a Jeep, it may have a lot of issues, but it's easy to bring it back up, and it's less expensive and it's faster to bring it up. So your entire architecture should be designed more for mean time to restore services rather than mean time between failures. So, that is your one design aspect. And resilience, again, one company which, as if you're a DevOps practitioner, would look at is Netflix I would say they may have the best practices for DevOps, and Kaios is another open source framework Netflix came up with to test their microservices. They bring the services down real time and see how resilient their entire application suite is. So it would be good if you can leverage such things in your application suite. So again, very popular sequence diagram from Just Humble. So all those threads are kind of failures. The idea here is the more you go here, this is more towards production deployments, right? So the more you go towards the right, the more expensive, the more time you are going to consume to, get the system back up and running. So the earlier you find your problems, like unit test cases, or even integration test cases, or even build time, or even at the development time, that's where you are going to save maximum time. So this is all about maybe more about testing. So I think I just gave enough introduction about DevOps, which might have bored most of you. What is VSDS? It's called as Microsoft Visual Studio Team Services. It's an offering from their Azure stack, Azure suite. So what it does? So we have agile development which focus more on plan, code, build. Again, when you add continuous integration in the mix, you add testing, and continuous delivery, you add even releases. DevOps spans for that entire deploy and operate spectrum, right? And VSDS is one application which can support that entire activity within it. And I don't think AWS has a really equivalent to that. They have multiple products to support this. So that's one difference with VSDS, where Microsoft tried to bring everything under one umbrella, whereas Amazon took like a Lego block approach, which typically AWS is. So again, what is the basic architecture? Very basic, very high level. We have your dev machines, your developer laptops, Macs, whatever, and then you have some your code repository. Again, all these things are again replaceable. Okay, even though VSDS offers all these things, you don't have to go to VSDS's code repository. You can bring your own, like GitHub. If you're a fan of GitHub, use that there. Build definition. Again, it is a sequence of steps, sequence of tasks, which you use to build your application. So it could be an Android application, Java application, iOS, or a .NET application. It could be anything, and VSDS has out-of-the-box steps for most of the stuff. And if that doesn't suffice, if you need to do something innovative or crazy, you have ways to custom code those components, or you can even custom script using Node.js and PowerShell. So one thing Microsoft has been really cognizant in the entire Azure suite is to be vendor agnostic to the extent where they are agnostic to their own products. So you can bring your own stuff, and they kind of went to, and that's one reason why VSDS is so successful. Sorry. By the way, VSDS was officially renamed as Azure DevOps last week. So whatever I'm talking is a little bit wrong, actually. So the second step here is, or third step here is release definition. So yeah, this is all about how you want to release your stuff. Okay, which environment you are talking about? Is it dev, UAT, production? So we have multiple environments, and all of them are handled, all the environment, underlying infrastructure, everything is embedded in release definition. Again, VSDS offers array of out-of-the-box tasks for you, so that you can just configure rather than building them. Or you definitely can build your own tasks, or you can custom script. So a lot of opportunities. And again, build and release definition, you don't really have to build in VSDS. You can definitely have a, let's say, Jenkins server building it for you and do only release. Or you can do like something like VSTS building it for you, something like like Chef deploying it for you. So it's very much like replaceable. And one core part about VSTS is agents. So that is something which you cannot avoid. So agents are, you can think of agents as like a slaves. So maybe Matt can maybe relate to those things. These are like slaves, which needs to run in every build and release machines. Not in every machine, build and release machines if you want to leverage that. So every agent is like kind of slaves which just are waiting for an instruction from the cloud, which is everything else, right? So once you trigger a build, once you trigger a release or test, whatnot, it just talks to the agents, the corresponding agents. It can be cloud, it can be on-prem, so it's all kind of architecture is possible. So the agents understand only two languages, Node.js and PowerShell. Again, the decision is more to be platform agnostic, so that you can execute an agent in a Mac, for example, or a Linux box. They use .NET Core. They don't. So it is platform independent, and you can run in any machine. You don't need a Windows machine to run agents. The last thing is target environment. That I was referring to, like if you are delivering to a mobile app, if you are delivering to again, when I said mobile app, I'm not talking about Windows phones. I'm talking about iOS, Android, or any kind of platform. Again, or you can deploy to AWS or your on-prem machines or Azure itself. So again, the only thing Microsoft might have done a little bit of vendor-specific work is deploying to Azure. So if you are deploying to you have tools for AWS, I'm not saying that, but when it comes to Azure deployments, you have a lot more out-of-the-box things available. So like if you're using Azure Container Services, you can spin up containers much faster than probably deploying to your own Docker swarm or Kubernetes. So that's it. I'm heading to the next slide. This is a little bit of detailed architecture. So I think I talked about pretty much everything. So VSTS out of the box gives code repo, build definition, release definition, and build artifact repository. If you're from Java world, think it as your Nexus repository. And again, you can remove any of these part and bring your own, but VSTS do provide this. And then your build agents or Mac build agents or Linux build agents, everything can live in cloud or on-prem. Everything is again replaceable when it comes to cloud and on-prem. And these are like the environments it can deploy to, by the way. Next one, I have a demo coming in about VSTS. So I want to cover these aspects: agile work tracking, code repository, how builds and releases look like, supported scripts, variables, how to set up variables, things like that. Give me a moment. So this is VSTS, my personal VSTS, by the way. So I start with something called dashboards. Think of this as like you can see pretty much stats of your team's code repository, status, how many people are working on things like that. The second tab is about code. So VSTS supports Git as well as their own repository standard called TFVC. Most of the people these days go only Git. Again, even though there is a Git, this adhere to all Git standards probably adds a lot more feature like branching policies and everything, which is very easy to set up. But you can definitely bring your own GitHub or any other solution. Again, if you have a Microsoft on-prem solution like TFS, it can integrate to that. So any Microsoft legacy, it supports. The second part, I don't want to go deep into each tab because we are running short of time. Again, this is for agile work item tracking. So that's one aspect of VSTS. I just added some tasks just to show you. So it supports Kanban and Agile, Scrum, workflows, you can do all your portfolio planning within it. You can set up hierarchy so that your leadership team can plan their epics, and then it can be broken down to features, and then it would end up each team's work items. So that can be tracked. It gives nice out-of-the-box reporting. Okay, sorry. Yeah, now this is more on the build side of the house. So yeah, as you can see, I didn't really write any code to any script to create this build definition, because they have something called .NET build template. I just used it. You have a Java build template. You can use that. So this kind of brings it everything, and each step I just need to fill in the blanks here, and that kind of helps me to create a build definition much faster. Probably I have been a big fan of Jenkins before, so I would say this is much easier for if you are not like too good with scripting. This gives you a UI way to create your builds much faster, and you can definitely copy this and tweak it to create a new build definition. I just want to show you the out-of-the-box build task I was talking about. So it starts with .NET Core. Yeah, definitely it goes to Android and App Center. We'll talk about App Center now. A lot of Azure stuff. CMake, CocoaPod. So you can see a lot of Android, Java, everything is covered. You can deploy to Kubernetes. This was new. Docker is supported. So yeah, Gradle, Grunt, Maven. So all those things are supported out of the box. Okay, and all you need to do is add it, and that thing will come right here in the left, and just configure it. So good thing is that you can even integrate with third-party systems. So if you have a Maven things, you have service hooks, which kind of talks to Vsds and exchange information. So that is also taken care. Yeah, a lot of other things like custom variables if you want to set up. And if you want to set up password, you can use VSTS, or you can use any service in Azure or AWS, because VSTS uses Node.js and PowerShell to script. So I think that's another thing I wanted to talk. Node tool installer or PowerShell. So if you add a PowerShell, you can custom script it. So basically, anything you want to do custom, you can write there. And obviously, VSTS comes with an extensive array of APIs. So whatever you are seeing here in UI, Microsoft has given extensive APIs. So you can definitely use that also to create your own workflows. You don't have to use out-of-the-box stuff. So coming back to the build, I will probably have a live demo shortly based on our time. This is the release part of the house. Oh, I forgot to talk about something. So let's say you want to do just continuous integrate. So for example, once I change this code, you want this build to run. It's pretty easy. It's just, in fact, a checkbox. All you need to do is how you want to trigger your this build. So I chose continuous integration. I can actually do scheduled also right here, or it can be on demand, where you come and click some buttons, it gets built. Coming back to the release is the next extension of build. So once your application is built, now you can deploy that to an environment, a production environment or a non-prod environment, right? So it says that I have attached a build, so that any time when the build changes, I know. So, and I have also made sure that continuous deployment trigger is enabled, and I can even set which branch I need to trigger it from. So should I trigger from dev branch, or something at the higher branch, like should I trigger from master or dev? So just for the demo purpose, I have only one branch, so you'll see master. But yeah, in your production environment, I don't want you to do that. So again, now these are like environments. So I have like what, multiple environments here. I have a test environment and a production environment. So all I have is within is copy files to one, share to the other, and that's the only one I have. So you can add multiple tasks here also. You can deploy to, as I mentioned, you can deploy to Kubernetes or your favorite public cloud. Production, all I have is again a file share copy. But yeah, in reality, you probably need to integrate with your ITIL system. That's the other part of the automation, right? If you have an ITIL system like Remedy or ServiceNow, you use those APIs, call them from here. And that probably can create a new ticket within the system, attach all the paperwork. Probably you can automate them to create a holistic experience for just automating your ITIL framework itself, so that you don't have to do that paperwork manually. So everything is possible here. Obviously, you will end up writing a lot of custom. But what Microsoft has done is, unlike olden days, they have a bunch of third-party integration. That's the other piece I wanted to talk about. So for example, AWS tool for Microsoft. So this comes with a suite of applications which so it talks to pretty much most of the predominant stuff in AWS stack. So if you want this system to talk to AWS, you better install this. And that way, and obviously you have multiple integrations. And this is open source. This is out in GitHub. You can see the code. And if you want to edit it, you just download it, make changes, and you have your own stuff. And that's one thing I have been doing. Like get steal shamelessly someone's work and extend it. And if you are a little bit courteous, just upload it back, and so that others can make use of it. Docker integration, and some of them are Microsoft, but most of them are, as you see, are from like individuals like you and me. So that gives a lot of leverage here, because essentially they don't really have to create something. If there is a gap, there are people who are looking into things and they can contribute right here. So that's it. I probably am ready for a very quick live demo. So again, I didn't talk about the agents. You might have seen the agents, right? So this is how an agents and agent pools look like in Azure. So you see, I have 2 agents within this pool. Pool is nothing but a way to group your agents. An agent can be a build agent or a release agent. Vsds doesn't care, but best practice I recommend is separate your build agent as doing only builds. Do your release agents who do only releases, because you don't want to get hold of large builds coming on the way. Like we have Mac build and Android builds running in the system, and they take maybe half an hour, maybe 20 minutes. And if someone is waiting for a production deployment, that's the last thing they want to do, wait for an agent to be free. So I recommend separating those so that you will have little bit wiggle room for your production deployments. But that's the system is agnostic, and that's where the governance part of the things come in, so that you don't have a problem when you operationalize these tools. So that's it. Yeah, you see, I have an agent here which is offline. So what I have done last night is that I installed a Vsds agent. So you see download agent. I can download an agent and install it in Windows, Mac, or Linux box. And obviously you will have to use the different commands. So mine is a Windows box. I used this agent. I downloaded, I configured. It was pretty I might have taken 5 minutes. Probably because I have done this many times. So what I'm going to do right now is I'm going to start that agent. It is offline. You see, it is red. Red signifies it is not running. So I have pre-typed this command run. What it is now doing is it is looking for its master. Where is my master? So now I think it is connecting. So it is now looking for something called capabilities. What capabilities is? Now this agent is scanning my computer and is checking, oh, what do I have here? Because that is really important when it comes to building something. If my computer doesn't have, let's say, Android Studio or things needed for or Gradle installed, it doesn't really want to route an Android build to my computer. Same goes with Java, .NET, whatnot, right? So that's why it is looking for my capabilities. Once it has the capabilities, it will register. Yeah, now it came green. It says that it is talking to cloud. It kind of found its master. Then it now says that my computer has all these things. Well, I didn't mean to install all these things, but yeah, that's what it is. It has found that my computer has all these stuff installed, and it now VSDS knows what this guy has, so that it won't take time to route a build and then says, hey, sorry, I can't build Java. This guy doesn't have Java. So that's the purpose of having that capability out in Azure. Now this is back in Azure, so now we can trigger anything from this, and it will use my computer as an agent. That's what I was trying to tell you. And I already have a very basic Hello World application. I use .NET. That's just because that's one language I am comfortable with. You can definitely use any other language you like. So I have done this. What I have done here when it comes to build is that I actually have told every VSDS that, hey, use Hello World 1 for building. Okay, so now this build knows that it needs to look for anything related to Hello World. Since I don't want to change any code, I will trigger this build manually. Okay, coming back here, all it has is some basic .NET code, and it first takes the code, and then the last step I want to show you, I am actually copying it over to my local location. Okay, and that is something I have just opened up here. This location, I'm sorry, artifact location. I have nothing here right now. So what I'm expecting is once I trigger my build, it takes everything from the VSDS Git repository. I should be able to see my build running and downloading everything to my local. Takes a bit of time to run, but you are having access to these logs while you wait. And it just says this is the client view. It doesn't say much. All it says is it used to be listened for jobs, but now VSDS is connecting back to the slave in your computer, and it's just running job. So while we are waiting for this, I wanted to show you one more thing here. You don't really have to create your own agent. You have out-of-the-box agents available here. These are called hosted agents. Obviously, these are hosted in Azure. But what they have done is, let's say you wanted Visual Studio 2017, you have it. You also have a Windows container option. If you are a favorite of Windows container over Linux container, then you can also see my local agent. You have a macOS hosted agent if you want to trigger your iOS build, but feel free to use your local Macs. If you want to set up a Mac in your data center, feel free to do that. And same goes with Linux. So it's all out of the box. Yeah, by the way, one statistics I heard from last year's Big Data Ignite was that from a Microsoft guy was 60% of Azure runs on Linux, not on Windows. So again, I think this guy has done. So what happened is that build process dropped stuff in my local. I just wanted to show you that this was the built app. So that's right here. So I think build is succeeded. Now let's see what is going on with release, because what I am seeing is there must be a release which must have kicked off right now. Just now it automatically kicked off a release, because I told that I have done continuous deployment. What it has done is it has created a release, and what I was trying to tell you is that release might have deployed everything to my test environment, which is again local. You can see 1058. A minute ago, it deployed that to the test environment, and I just created another folder just to mimic the production. It just deployed into production also. Yeah, obviously, when you create your build pipeline, this is just from code to build to release. But when you really deploy, right, you should definitely have your unit test cases written, static code analysis to be done, a lot of test cases to be automated, a lot of other quality security scan, performance tests. Everything should be part of your deployment pipeline. And that's kind of beyond the scope of this session. So I'm coming back to my slide deck here. I think I talked about most of the stuff. Oops, I'm sorry. So I just wanted to show this. So what do you do for builds? You just need to define a build, and you can start building it. And you need to attach a code base and add build tasks. From a release standpoint, you need to define a release. When you define a release, you need a build definition attached, then create your environments. Then the second step is release a good build to an environment. Here, first you need to deploy to test, then deploy to UAT, deploy to production. Obviously, if you have more than 3 environments, you need to add that. Then I also talked about build and release tasks, build and release return. Oh yeah, you can have some retention policies. You don't have to manage your build artifact on-prem. You can have VSDS manage it for you. And if yes, you can have nice policies like, okay, delete my builds, like successful builds after 30 days, or retain my production builds for 1 year. So I think VSDS out of the box gives up to 1 year to retain your builds. But yeah, that's something you can configure. CI/CD triggers we saw, third-party tasks we saw, custom tasks. Obviously, custom tasks is all about PowerShell and Node.js tasks I was talking about. Extension, third-party extension, marketplace. Then integration with other platforms. Obviously, Azure, Jenkins, Docker, Maven, Xcode, Android, SonarQube. Obviously, we have REST APIs. Okay, the other part of the demo is not live. You can do your test plans. You can do performance tests through VSDS. You can do automated tests. All those things are available right here. And obviously, these all use Azure computing. I think that's where Microsoft is making money. And you get, for performance test example, you get 20,000 minutes performance test free every month. When you look at it, you may think that it is pretty high. But let's say you are mimicking your load with 100 users. Now divide 20,000 with 100. You're just getting 200 minutes. That means it could be just one test probably for my app, my run actually. The other one I wanted to talk about mobile DevOps, and this is something most of the companies haven't, most of the providers haven't sold, right? In one platform. So Android Studio, Swift, or any of that, any of the iOS platform. You don't or Microsoft, development kits for mobile. You don't really need a different tool to solve this. All you do is use Git, your own Git or VSDS Git. You just need a build definition with the right task out of the box again. Microsoft has bought this company called Hockey App, and now they are working on a new beta version called Azure Mobile App Center. That's another offering from Microsoft on mobile DevOps. So what it does is, when someone changes the code in their dev machine, you get a continuous deployment pipeline all the way to your end users mobile, where you get a real-time updates. So right now, I recommend using this for dev activities. Your QA gets automatic updates, but obviously there are features which can deliver your mobile app updates directly to users, which is kind of still debatable. Do you really want to send updates every other day? I think this is the last slide. I just wanted to talk about the maturity when you look at your DevOps roadmap. So I'm sure most of the companies have some kind of DevOps program in place, but let's assume a company doesn't have. So that's all manual. Many companies are here. Like they have some kind of automation. Maybe outside VSDS, If you really want to onboard VSDS with all the kind of principles we talked, this is a very good start. Then I would say if you really want to start with your code. That's the easy thing. Try using Git, VSDS Git. And very easily, if you're using a Java or .NET app, you can do a CI. continuous integration. So just start there. Then after some time, once you are set here, you can definitely start doing a continuous deployment to your lower environment, non-prod environments. Then start with your heavy automation when it comes to QA. And that is again a segue to QA strategies. You better start re-look your QA strategy, start doing a lot more unit tests and some integration test cases and lot less UI test cases. But yeah, automate your test cases. That's a part level 3. Level 4, if you start with TDD, automated rollbacks in every environment, TDD, test-driven development, this is the ideal level to start test-driven development for you. Level 5, automate your DB deployments. So VSTS has ways to automate deployments. You can always use third-party integration, things like Redgate or Liquibase, do that. Then automate all the repetitive tasks. I talked about ITIL change management. A good example, because with DevOps and Agile, you deploy frequently. Anything you do repeatedly, script it and automate it with VSTS. And add a lot more code quality. This is the ideal time for you to introduce static code analysis like SonarQube or I'm not getting the names. So SonarQube is one popular theme here. And a lot more feedback, a lot faster feedback. Add performance testing to your deployment pipeline. Add security scan like Qualys to your pipeline. Then level 6, this is the time you need to really look into your application development strategy. Refactor your apps. Start bringing domain-driven design. Start bringing more microservices-based architecture. This is exactly, but don't change your platform yet. Start refactoring your application. Engage your business and try to find an owner for everything. Try to find domains. Then you refactor all your services into microservices, and that also involves database also. At this stage, you have a hell lot of microservices, and you are kind of thinking what to do with that. And you probably might have started thinking about Docker and containers. This is the next steps. Level 7, make application infrastructure independent. So start bringing something like Kubernetes or Azure Service Fabric. Start looking at some kind of microservice platform rather than hosting your microservice here and there. Start looking for a platform and refactor. Then, if you don't have it, do something to automate your infrastructure. This is the ideal time to start looking at how do I provision an environment and bring your infrastructure into the fold. That's here. And ideally, I recommend something like in this day and age, I'm recommending something like Kubernetes for most of the companies, but again, there's no one fit for everyone. That's where you need enterprise and solution architects looking into your stack and recommending your own solution. Last one. Once you have this, now you are at a state of an Amazon or Netflix. This is the time you wanted to do probably the holy grail of continuous delivery, just humble envisions. Commit to master branch. So I'm going back to code. You have multiple feature branch. Eliminate it. You have one master branch. Your infrastructure is elastically scalable. You have probably 100 services. At one point, next time it would be 10. At night it would be one instance. It is elastically scaling up and down in a public cloud, most likely, and private cloud hosted within your network infrastructure. Then you are not going to release. It is your business who is going to release. You just deploy, and you have feature toggles taking care of your features, and your business is empowered to turn a feature on and off at their will. So that is the holy grail. And this is probably a roadmap for most of the medium to large size applications, a good 2-year investment. So what I was trying to do is do your ROIs, and most of your ROIs comes in the earlier phase. The more you grow here, you will have diminishing returns from your investments. That said, I'm done. Few references I have taken: VSTS APIs, 12-factor app. Again, all this knowledge is a lot of working knowledge and lot of reading. I'm done. Any questions? Okay, thank you. Thank you for having me.